let's learn about the shells and their subshells in the atomic structure so that we can understand the electronic configuration in a much better way, in a more better way. Let me introduce you myself first. I am Momita Seth. I am a maths and science teacher for the last 10 years. Teaching is my passion. I have done my graduation in chemistry major and have done a BTech from one of the best university of India. So now you know me. Let's start about the shells and the subshells of the atomic structure. Okay, so we already know that the shells, we number them as K, L, M, N. Okay, so the first shell, which is closest to the nucleus, we tell it as K, and for that the N, that is the first number, we number it as 1, or we can also tell is this is the energy level. This is the energy level. N equals to 1, K is 1 is the energy level for the K shell. So the number of subshells will also be 1. Okay, so the number of subshells for a shell will also have 1. And the N is 1, it will be 1. Now what will be the energy level of a subshell? It is numbered from 0 to n minus 1. So when it is 1, so it will start from 0. Now your n minus 1 is 1 minus 1 will give you 0. That means it has got only one subshell whose energy level is 0. So for L, n is 2. So it will have 2 subshells and the energy level will be 0. And next comes 2 minus 1, that is, I told you it will start from 0 and its energy level will go till n minus 1. So 2 minus 1 is your 1. So that means it will have 2 subshells. With M, that is the third shell, where n is 3, it will have number of subshells 3. How the number of subshells is 3? We can, from the energy level also we can find out. That is 0, then 1. Then 3 minus 1 is your 2. Okay, so till 0 to n minus 1 will be the number of subshells. So it has got this 1, 2, 3. So that is why it has got 3 subshells. So energy level will be from 0 to n minus 1. So n minus 1 here is 3 minus 1, 2. So 0, 1, 2. Similarly for the fourth shell, we will have 0, 1, 2 and 4 minus 1 is 3. So till 3, okay. So that means 1, 2, 3, 4, it will have 4 number of subshells. So now divide it like this. So when 0 is the energy level, that subshell we call it as S subshell. When it is 0, again we have 1 S subshell and 1 P subshell. 1 is for P subshell. Okay, so that means in first shell we have only 1 subshell. 1 is in here, we have 2s and 2p, 2 subshell. In third we have got 3s, we had got 3p, and this 2 stands for d orbital, that is the d subshell. It is d orbital. Again 0 is for the fourth shell, 0 is for fourth s. So 4p, 4d and 4f. So these were the 3 stands for f orbital. Now s orbital can hold 2 electrons, maximum 2 electrons. P orbitals can hold 6 electrons. Similarly again, then your d orbitals can hold 10 electrons. F orbitals can hold 14 electrons. Now how this is coming? We have to know again little more about the P, D and F, and we again have to study about their energy levels. Then only we can understand how the electrons are arranged in them. So we will first understand what is their energy level and how the electrons are arranged in them, and then we will learn how to write the arrangement of electrons in these subshells. Okay, so let's start with s orbital. S orbital is shown like this. Okay, then your p orbitals have got again 3 types of p orbitals are there. So we show it with 3 compartments. So this is your p orbital, this is for s orbital. For d orbital 1, 2, 3, 4, 5. It will have 5 compartments. So for d orbitals there are 5 types of d orbitals. So we show 5 compartment for d orbitals, and each of this, remember, each of these compartment can hold 2 electrons at a time. So maximum number of electrons in it can be 2. And when we are filling the electrons in it, they will be in anti-parallel spin. Okay. So when we are filling up, suppose 2 electrons which is coming in is orbital, so it will be like this and like this. They will be in opposite spin. Now suppose I have got 1 electron, so it will from S. Next it will fill, first always it should fill S because it has got the lowest energy 0. Then P has got the next energy level, that is 1, and D has got another next energy level 2. So like this, first S will be filled, then P, then D, like this it will go on. So now when the electron will come, 1 electron will be filled like this. The next electron in p orbital will go to the next shell of the p, next compartment of the p, not in the same orbital. Now when you are filling up this, remember they will fill up singly and in the same spin. They will be in the same direction. They will spin in the same direction. So second one will also go this way. Third one it comes, it will go here in this way. Now the fourth one, when it will come, it will again go this in this compartment and in opposite spin. Okay. So fifth one will be like this and the sixth one will be like this. Now again, after this, if the 9th electron comes, it will go to D. Then 10th will be like this. This way it will keep on going. Like this it is been filled. Okay, understood? Now suppose you have someone have drawn in P shell. First in P shell someone has drawn the first electron like this. Not an issue. The second electron will also be there in this way. Now again when that fourth electron comes, it will go fifth and it will go this way. Understood? So you have to understand that when the direction in which you have introduced the electron in the p orbital first compartment, in all the compartment, when it is getting singly filled, they will be in that spin. Now we have to understand the energy level of each of the subshells. Okay, let's start with 1s. So for 1s, the energy level, the 1, it is shell number 1 and subshell is S. So 1 plus 0 is 1. So 2s, it is 2 plus 0, it is 2. 2p, it is 2 plus 1, 3. Then comes 3s, 3 plus 0, 3. Now both of them have got the same energy level. So which one will be filled first? The one with the least major shell number, with the least principal shell number will be filled first. So here the principal shell number is 2 and here it is 3. So obviously this one will be P will be filled first. Okay. So next comes 3P, will be 3 plus 1, 4. Then 3D will be 3 plus 2, 5. Then comes 4s, 4 plus 0 will be your 4. Now we can see that 4s orbital has less energy level than the 3D orbital. Okay, as well as because this is, so after this one also has got 4, 4. Now the principal shell value here is 3. So obviously 3p will be filled first, then 4s. So after 3p, the electrons will move to 4s. From 4s, it will move to 3d. Now next, where it will move? 4p. Let's see what is the energy level coming. 4 plus p. P we know. Let's write it over here. S is 0, p is 1, d is 2, f is 3. So we will not go to that far. For F we will not study. We will study T, Leo, D orbitals. So let's see what is 4p. It is 4 plus p is 1. It is coming out to be 5. So again 3d and 4p have same energy levels, but principal shell number is 3. It is less in case of 3d. So from 3p it will be 4s, 4s to 3d, and 3d to it will come to 4p. So how the electrons are filled? So 1 is to 2p 2s, then your 2p, then 2p to it will come to 3s, then it will go to 3p. So S and P, when they are filled, it gets 8 electrons, right? So that is why we are telling there should be 8 electrons in the outermost shell. So after 3p, 3d will not be filled. As we have seen here, what will be filled? We will fill after 3p, it will fill the 4s orbitals. So from here, it will go to 4s orbital, and then from 4s it will go to 3d orbitals, then 3d it will come to 4p orbitals. So this way the electrons are being filled. Okay, so now you will understand why we have that after argon, when you are going to your potassium, the electrons are filled in 4s orbital, not in 3d orbital. Okay, so let's see. Your hydrogen will be 1s, your helium will be 1s2, then your lithium will be 1s2, 2s1. Okay, so this is how we should write the electronic configuration. So for argon, it will be 1s2, 2s2, 2p6, then 3s2, 3p6. So it is all filled orbitals. Now when you are going to potassium, it will be 1s2, 2s2, 2p6, 3s2, 3p6. No, not 3d1. It will be your 4s1. Okay, so see, in all the outermost your valence shell, it has 8 when it is we are in that neon, it was your 1s2, 2s2, 2p6, it was a noble gas configuration. Now for argon, it is 1s2, 2s2, 2p6, 3s2, 3p6, again noble gas configuration. For helium, 1s2, because S can have only maximum 2 number of electrons in its shell. So only helium is little exceptional, where 2 electrons makes the shells fulfilled. So helium is the first noble gas, then comes your neon, then argon. Like this it keeps on going, and this is how the electronic configuration is been filled, and this is how the energy levels are decided, we decide, and the atom decides where the electrons will go and will be filled. So I think this video will help you in understanding the electronic configuration better way.